just in the last little bit in, of course, that was just a 7. But actually this would be the table to copy down. I think it would be better to copy this table down. Great earthquakes, there's 8. Over 8.0, you get 1 or 2 every year. Okay, detected but not felt down at the bottom, 2 to 2.9 on the Richter scale, and you get 300,000? Lordy, that's right. It's amazing to think there's lots of earthquakes. When everybody talks about earthquakes, they think about the big ones. Okay, and the big ones are devastating, of course. But there are 300,000 earthquakes every year that are very, very tiny. And so scientists are still studying those. It's not just the large earthquakes that we study, although that's the one that gets all the attention. All right. Okay. That's a skip. Or actually, this is not true. Regular does need to do this. We're going to talk about 3 more topics right here. And yeah, first thing, the 1906 intensity animation, the USGS intensity reports, and sand volcanoes. You know, at this stage, what I want to do is I want to turn this over to our friends, Mr. and Mrs. Mosier from Columbine High School, and they're going to talk to you about some of these other topics here. So let's listen as they teach us some amazing things.
Okay, so here's the 1906 earthquake, and what they've done is put intensities, just based on reports, kind of as it radiated out through the Bay Area. And again, this was from the 1906 earthquake. Be reading about that a little bit more in the book, but you can tell right along that.
About 25 seconds after the actual earthquake, look at how much damage and how widespread it was. And it's still shaking.
And you can see that most of the damage is being centered, the highest intensities are being centered right along the San Andreas Fault. That's the line that's going right through here. Different areas of San Francisco, because there was such a high intensity that occurred, very much destroyed. The city of San Francisco basically didn't exist after this earthquake took place. But just looking at the different intensity values, now we're just a little over a minute from when the earthquake first started.
I think the earth actually shook for like 90 seconds.
Yeah, it was a really long earthquake.
So we're still in the middle of this earthquake, even from the point where we began talking. There we go. That was quite an intense strip of earthquake when you look at it all hitting intensity level 10 and above all through there.
So USGS now has a part on their website called Did You Feel It? It's on the earthquake page, and if you are ever in an earthquake, you can actually go to the USGS, click on the earthquake hazards, and fill out a report on Did You Feel It? They'll ask for where you're located and what you experienced, and they'll use that information to produce different intensity maps.
And you'll be so smart, you'll say, well, to me, it felt like it was a Roman numeral 4 in intensity.
On the modified Mercalli.
On the Mercalli intensity scale. Yeah, that'll show them. They'll say, what the heck? These kids had brilliant science teachers!
So here's the intensity map from the 1906 San Francisco earthquake, and you can tell right around the San Francisco Bay Area, very high intensities. There were some effects from the earthquakes felt as far as Carson City, Nevada, Southern California, very, very large intensity map from that earthquake.
And you know it's an intensity map because of the Roman numerals, and it says intensity on it. Well, here's another intensity map that took place on the eastern part of the United States years ago.
In 1811 to 1812. It is on the New Madrid fault system. Just from this one, and well, from the series of earthquakes that they looked at, and we'll look at this particular series again in a further vodcast. You can see that the area was very large, very high intensity, very close to the epicenter of the earthquake, and then radiated out all the way onto the eastern seaboard as well. If we look at the two of those side by side, you can tell that the San Francisco earthquake didn't go quite as far. Part of that is there's mountains in the way. The New Madrid series of earthquakes, it was felt, wow,
pretty
forever.
Intense. It also hit a way higher intensity.
So hey, Mr. Mo, why isn't this intensity map going on the other side of the Mississippi?
Well, in what was that year again? 1811?
Yeah.
I don't think they had anybody living that far east west of the Mississippi. I don't think they discovered Nebraska yet.
So it shows you that
St. Louis was about as far as they had gone.
So that's why the map is only half. It's not that it didn't have any effects over there. It's just there wasn't anybody there to tell them.
Nobody to interview.
So the last cool thing, sand volcanoes, very bad term for these, but these
Horrible
can
term.
occur. These can occur during earthquakes, and this is because the ground underneath liquefies. There's sand underneath the ground. As ground shaking takes place, that sand just pops up out of a small hole in the ground and can pile up around and form what they mistakenly call sand volcanoes.
It's kind of like a cinder cone, but it's really not cinders.
No, it's sand.
We would call it a silicon dioxide cone. There.
Okay. Wow.
A silicon dioxide cone.
All right, there we go. But pretty cool.
Well, that was great. So hopefully you now understand more about how scientists study how big an earthquake is. How big is it? It's very, very big. Well, maybe a little bit smaller. And so that's what we're going to learn about. Or you just learned about today, right? So we'll see you in class or, whatever. Bye.